All right, we are back. So, the goal now is to figure out how we can implement RAG with all of the research that we done earlier, which is specifically around, um, well, this reference document, this reference implementation we have here, and also this table showing us like different techniques that we can apply. Um, cool. So, I guess the steps we're going to follow here are I'm gonna see if we can. Huh, let me see if we can use LangChain to help us with some of the setup stuff here. Specifically, we want. So let's break down the tasks, right? First, we're going to vectorize the source laws, all of them, um, and then parse query, answer query without referencing source laws, perform vector search on answer, and then generate the final answer. Hmm. But when you say answer query without referencing source laws, I mentioned like the output is just going to be an entire contract. And then when you're going to do a vector search for an entire contract, that's just going to be, I mean, it's going to give you horrible results. Is that even going to be better than not using RAG at all? Hmm. I don't know. I'd want to test that out. Like before trying any of these optimizations, I think the basic thing that we can do is implement it in the most basic form, and then move on to adding like layers of complexity to see if we can get better results. And thinking about this now, commercial companies law. I think you can feed the entire commercial companies law into this. Based on the proposed three contracts that reference demonstrate yeah, basically I want some examples of contracts that we could oh, that's too long even with the latest GPT model. Oh, I'm surprised. Oh, I can't scroll to the top. It's so frustrating. Um, okay. So maybe instead of attaching it this way, we could. Mhm. Okay. Let's see what we come up with. Okay, I just asked for 3. Oh, okay. Shareholders agreement for public shareholding company. Okay, cool. LLC operating agreement. Cool. Okay. All right. These are good examples of use. So essentially, what we are going to do is the first step is vectorize source laws, parse the query. Parsicle. What does that even mean? So perform vector search on query. Okay. Yeah, seems simple enough. I mean, this is just gonna be like your typical RAG. We're not doing anything special here. So maybe we can even reference. Um, does it have LangChain? Oh, it does. And then there's LangChain.js. Oh, I added that one. LangChain. Okay. What are we gonna use? I guess. Yeah, I mean, for the vector DB, we're probably just gonna end up using Pinecone. So let's just and write a method that accepts a clue. That sounds pretty similar to what we're after. Um, so I think, yeah, I think we're ready to go. I don't know if I should wait until it's done crawling all of that. I mean, that's pretty intense. I'm actually just setting up a Pinecone account here. Pinecone. All right, so I'm seeing this. Apparently, they just introduced some serverless thing. Um, I don't actually know what this is about. Okay. Okay. Um, I guess I'll go ahead and try this out. Uh, all right. So it seems like it's not going to change a whole lot. The difference would be that you specify like some additional thing. Oh, this is done. So let's go ahead and have that start generating code for us. Seems simple enough. Vectorize, upload, write a method that accepts a query, perform the search, feed and retrieve documents. Okay, nice. I should probably say I've never actually used LangChain before, so this is going to be new territory for me. Probably want to install LangChain though, right? Okay. Get started. Okay. No way it's that short. Chain dot invoke, and then you're calling chat OpenAI. Load text line, no way. Okay. Folder path, new document, and then you pass page content. Okay. Interesting. You just have to call it HNSW lib. Weird that it doesn't reference Pinecone anywhere here. Pinecone? No. I mean, it didn't mention it in the prompt though, right? Uploading them to Pinecone. Quick start. Okay. Yeah, it seems simple enough. It's not what they're. So here it's saying at LangChain slash OpenAI. That's different than the invocation they're making here. Ah, man. Okay, interesting. I think you need to do npm init first. back. Sorry about that. I had to take a quick break there. Let's see. Where were we? And it doesn't look like this is actually the code that we're after. Because code is not the same as code that we see on the LangChain site. This is so frustrating. So incredibly frustrating. Hmm. We can then initialize the model using that. So, I mean, I don't think this is going to work. It's so obvious that it's not going to work, actually, and this is just a waste of time. The only thing we could use is probably this bit over here. Um, yeah, I think that's pretty much it. And maybe the sequence, like the way it actually does this, I don't know. Yeah, let's use this. I'll keep the, I'll drop these. And then your chat model. Okay. Hmm. So chat model dot invoke, and then you pass messages. Okay. I guess you can keep. Okay, prompt template. Okay. Yeah. Prompt dot format. You got runnable sequence somewhere in there. Not LangChain, Pinecone. Oh, cool. You can actually do this without using LangChain at all. This is amazing. This is awesome. Okay, cool. Let's use that then. We don't need to use LangChain. Pinecone. Yeah, embeddings. Yeah. dot from text, and then you just need to make sure that so memory vector store. Oh, you can call from documents. Okay. All right. Cool. Create a new index from a loader. Text loader. Maybe you can use a text loader. Oh, they have RAG. Okay. Directory loader. That's exactly what you want. We'll call the static from language method to create a splitter that knows how to split JavaScript TypeScript code. Huh. Cursive character text splitter. Okay, so you call recursive character text splitter. Custom text splitters. I think that's what we're after. You only need to supply a splitter in a single method. This takes a string and returns a list of strings. Will be used as the chunks. Yeah, nice. I think this is exactly how I would do it. Text splitter, you're going to pull from law text splitter. So what do you do with splitter? Split documents. So doc output. How do you feed it the documents? Okay. All right. I think we're getting there. So we've figured out a way to split documents based on our custom splitter here. And the custom splitter, just takes into consideration, oh, chunk size. Is this in words? What is this? Chunk size. Um, Number of characters. Measure chunk length by number of characters. Okay. Yeah, that's not what we want. You know, do 10 characters at a time. That's ridiculous. Um, Maybe we could do like what's a typical article? How many characters here? 673. Let's get one of the longer ones. Okay, this one. 99. That's 1,500 characters. Okay, definitely looks like it was one of the longer ones. So 1,500. Let's just call it like 2,500 max, and then you could do like 50 overlap or 250 overlap. Okay. So you're going to split by chapter and then whatever. So chapter. Um, yeah, that's not going to be that's going to be text. And then, um, do they have to start with chapters? Ignore all that, and then no, I would skip chapters actually. So we just split by. Oh, why are the first ones Article 3, 4? Okay, so yeah, I guess we just ignore those. The ones we would actually be interested in are the ones that have brackets. Okay. Okay. So this is doing the splitting. It should also do the actual embedding of the documents. Um, I know what this retriever thing is about. Metadata. I wonder if that would actually be relevant. Um, Now that I think about it, like maybe you could pass it like before actually performing the search or feeding like an entire section. You would, I'm thinking like either summarize the article since you only have several hundred of them, and then feed that into a list and ask it like ask the LLM which articles would be most relevant, and so that way you're selecting from 200 whatever articles, pick in say like the top five, and then you're feeding those in. That could work. It's actually not a bad idea. Um, so things we could try. So in this case, you wouldn't. Um, I guess in this case, you wouldn't need the vector search. No vector search at all. Maybe. I guess maybe worth a shot. Um, Vector stores. Where are like actual guides for implementation? I saw one for RAG. Yeah, it's this one. Oh, here it is. This is a Python one though. RAG over code. Yeah, this one. Splitter. Okay. Then retrieval Q&A. Vector store dot has retriever. I think we already have that. Yeah. Um, okay. We'll set up our model and memory system just as we do for any other chatbot application. You'll pipe the string output parser. All this will do is take an input output from the LLM and store them in memory. Now we can construct our main sequence of chains. Um, wow, okay, this is so confusing. I think the easier way would be to just feed this into ChatGPT and generate the code we need. Based on this example, Okay, so now I just feed it the code. All right, let's go. Nice. Okay. You're not going to be using runnable sequence then, huh? Right. Sequence is another thing. I don't think that's a thing anymore. Where's prompt? This is so confusing. I have no idea what all this stuff means. Generate answers chain.invoke. Where's chain defined? I don't think we have chain defined. Yeah, and this is kind of useless. So I have to fall back to actually doing this myself, which is painful. Okay, this is building it using Python. Hmm. Oh, okay. I hadn't seen this before. In-memory vector store can be saved to a file. Mm, okay. I guess it's an alternative to using the memory store. Cool. These are great examples. I think we'd be able to go through the cookbook and get a sense for how things work. Um, and they start with simple things and then they sort of layer on complexity. So I think that's a great place for me to get accustomed to what they're doing. For the purposes of this, all right, let's see if it actually I just do anything here. Um, uh, LC.rag.generate. Are you kidding me? What is this rubbish? What a load of crap. Okay, it has no idea what it's doing. This is GPT-4. Um, referencing. Oh. Mm-hmm. All right, so let's see if we can fix it. Otherwise, if not, then we'll have to go through the process of actually reading the docs, understanding how LangChain works, and then picking and choosing like the specific pieces that we're going to need to get this working. I'm hoping this will work and I don't have to do this all myself because honestly, I could really use a cup of tea right now. And this looks like it's going to take a while. Oh, there's two folks tuned in. Hey, everyone. Um, so to sort of catch you up on what's going on, I'm trying to implement RAG to build a simple solution that allows me to generate legal contracts using AI. And specifically, I want the contracts, the generated contracts, to comply with local laws of a target jurisdiction. And we do this using RAG. So I downloaded a bunch of laws for Bahrain as an example. And you can see what the laws look like. Basically, they're a bunch of articles. So that's sort of the atomic unit here. And the goal is to vectorize all of those laws. And then whenever you ask to generate a contract, we would pull in the relevant laws, the laws that are relevant to that particular contract, and feed them into the OpenAI call so that we generate a contract that's hopefully compliant with the specific laws that are relevant to that contract. So far where we've gotten stuck is this particular step. Well, sort of putting everything together. I'm trying to use LangChain, which I haven't used before, and yeah, I'm hoping that we'd be able to get this into a working state. We set up the splitter. Where is the splitter? New LaTeX splitter. Okay, yeah, cool. So, model 3.5, vector stored, define prompt. Okay, all right, and generate answer. Cool. I think we could use all of this. And we should make sure that you can keep the LaTeX splitter because we're going to need that. All right, so let's take stock of where we're at. Oh, I put that up here. Okay, cool. So we don't actually need that here. LaTeX splitter, cool. It splits it up into articles that we can then use, vectorize. So load and split documents calls. Uh, I mean, it's gone back to loading them individually, whereas previously I had it use a directory loader. But oh well. All right. So, okay. All right. I don't like this splitting mechanism that we're using here. I actually prefer the old one. Oh, we weren't even using it. You had a directory loader. Cool. Cool. I don't know why we're using HNSW instead of the last one that we had. Oh, yeah. Run this. All right, we're gonna take a quick break and be back to